everybody, this is Rudra Pradhan here and welcome to BMD lecture series. Today we are going to discuss on inferential analytics and that too the topic of discussion is on confidence intervals. In the earlier lectures we have already discussed hypothesis testings by using various test statistics. Typically we have discussed the problem related to Z distributions, problem related to T distributions and problem related to chi-square distributions. So, the idea behind all this discussion is with respect to comment on population parameters. So, we start with the game by fixing population parameter and then with the help of sample statistics we have to validate the population parameters. So, that means, the idea is here to check whether this sample statistic is unbiased estimated to population statistics. If not, what is the kind of biasness in the particular systems or in a kind of problems. So, the ideal rule is that your sample should be sample information should be converged towards population informations. If there is a huge difference or huge deviations, then the decision making process will be getting affected. So, sometimes if there is a huge deviation, then the population parameter need to be changed. So, obviously, so here the idea is we have to create a kind of confidence interval with respect to population parameters. Earlier our idea is to test the kind of things and then comment about the population parameters. And here we have to create a kind of concept called as confidence intervals. So, let us see how is this particular structures. So, in the process of these are all actually lecture highlights and this same kind of highlights we will continue, and because it is actually a part of the hypothesis testings. Earlier structure is like to validate the kind of concept, but here with the given situation we have to create a kind of confidence interval for population parameter. So, for instance, a population parameter is nothing but called as mu. So, we like to know what is the lower range of the population parameter and what is the upper range of the population parameter, and by using different test statistics. So, that means, we will solve some of the problems by using a Z distribution, T distribution and chi-square distributions. So, let us see by using all these test statistics how we can create a confidence interval for a population parameters. So, for that, so we first like to know the structure of estimations, and by the way there are two different estimation process, point estimation and interval estimations. Point estimation is nothing but actually single value which is obtained from the samples, but interval estimation is nothing but actually it is a range of values calculated from a sample statistics. And so, the standard example is standardized statistic, that is nothing but called as Z statistics. So, here using this standard distribution we have to find out the kind of confidence interval for the population parameter. So, now corresponding to the structure of point estimation and interval estimation. So, the standard example is the mean of a particular sample, say x bar. So, that is nothing but actually summation x by n. So, that is actually it is a single value that describes the kind of entire series, and in the case of interval estimations we have to create a confidence interval for this particular mean value. So, typically the idea is here. So, we have actually mean value is x bar, and then corresponding to this mean value. So, we like to create a population parameter and that to lower limit of the lower value of the population parameter and upper value of the population parameter. So, that is what the kind of structure which you want actually in this particular lecture. So, this is what the upper bound and this is what the lower bound, and this is sample statistics and this is also sample statistic and this is population parameter, and this is what the actually Z distribution and this is what the Z distributions. So, now in sum, so when you have actually x bar, by using this particular formula, So, you can able to find out the lower value and you can find out the upper value. So, that means, the lower value will be x bar minus z sigma upon root n, and the upper bound will be x bar plus z into sigma by root n. So, this is how we have to create a kind of confidence intervals. So, before we go for the kind of testing and the kind of examples. So, let me give you the kind of snapshot what is exactly the confidence interval and how is this particular structure altogether. In the next slides, so I will highlight the kind of concept about the confidence interval. So, this is what actually confidence interval, and what we are actually looking to know. So, this range and this is the structure entirely called as confidence interval, and this is what the population parameter, and population parameter, this is the left hand side zones and this is the right hand side zones. And now, with the help of hypothesis testing again, so we can in a position to create a confidence interval for the population parameters. So, now earlier with respect to population parameters, we like to test the process, and with the sample statistic we will give comment on the population parameter. Here we are adding something extra, that with respect to the population parameter. So, we have to find out the kind of confidence interval. So, that means, sample statistic will be used to create a confidence kind of confidence interval for the population parameter. This is what the kind of objective in this particular lecture. So, let us see how it is actually coming in a kind of some kind of example. Okay. So, this is how the typical range. So, since we are giving emphasis on both the sides. So, with the fixing alpha is the type 1 error, then alpha by 2 will be coming this side and the remaining alpha by 2 coming this side. So, then this is the confidence interval, the entire zones, and since it is a symmetrical distributions, then 50% will come this side and 50% will come this side. So, actually we have no business about the 50% observation and 50% observation. So, we can get to know more details once you take a standard examples, right. So, let us see how is this particular structure altogether. Then in this case it is the same things, but we are putting actually means since total probability is exactly equal to 1. So, when you are putting alpha this sides, that means you have 50% of alpha this side and 50% of alpha this side, then the remaining portions will be again divided into two equal parts, because it is a bell shaped curve, and as a result, so 1 minus alpha by 2 will become this side and 1 minus alpha by 2 will be this side. So, that means alpha in one, so there are two sides actually, alpha and 1 minus alpha. 1 minus alpha actually called as confidence intervals, and then alpha is the kind of rejected zone. So, since it is a two-tailed kind of game. So, both the sides the appearance will be alpha by 2 and alpha by 2, and then the remaining 1 minus alpha. So, it will be 50% left to the mean mu and 50% right of the mean mu. So, that means corresponding to the z distribution 0. So, 1 minus alpha by 2 will be in the right side and it will continue up to, so this range, and again this sides it will continue up to this range. So, as a result, so it will give you a kind of confidence intervals. So, let us see here how it is exactly coming. Okay. Okay. So, this is what actually the kind of structure. So, since it is a altogether total probability equal to 1 and corresponding to alpha. So, the probability of this particular confidence interval will give you the kind of concept called as 1 minus alpha. So, that means, the 1 minus alpha altogether it is nothing but actually probability of the entire zone. So, that means, here. So, once you find out the mean value of the sample statistics and follow the z distribution, then the lower bound and the upper bound, the entire confidence interval will be represented by 1 minus alpha. So, in order to understand better, so let us take an live examples, right. So, we will take a live examples and then we can discuss the details, right. So, okay, so this is same things. Okay. So, in this case actually, so what we will do here in this particular examples, we are fixing actually 95% of confidence interval, but as a result by default alpha will be represented by 5%, and since both the sides we are targeting, then left side will be 0.025 and right side will be 0.025, and then out of 95%, 0.475 will be in the left side, again 0.475 will be in the right side, then it will be giving you kind of structures. See here, so the so far as a confidence interval is concerned, so this is actually population parameter, this is population parameters, and then this is population parameters, and then so the lower bound will be this much and the upper bound will be this much. So, that means what we need actually to create a confidence interval, we need first sample statistics and then the z value and the sigma of this particular series and provided a sample size, right. So, that means having let us in this particular examples we are fixing, let us assume that x bar equal to 153 and standard deviation equal to 46 and n equal to 85. So, now having this much of informations, then our target is what should be the range of population parameter mu. So, that means with the given sample information we are trying to comment on the population parameter, that to create a kind of confidence interval. In the earlier lectures what we have done actually, so with respect to population parameters we obtained actually sample statistic and then we get the test statistics, then we like to validate the test statistic whether it will be in the rejected zone or accepted zone, that to acceptance of null hypothesis and acceptance of alternative hypothesis. So, that since both cannot go up simultaneously, one will go at a times, and that will give you the a kind of status about the population parameter. But here the game is a little bit different. So, that too with a sample statistic and the choice of a particular test statistic, we have to create a confidence interval for the population parameter. So, the standard example is here. So, now in this particular examples we are using a z statistics, and that too for this confidence interval. So, the requirement is you must have a sample statistics, that is x bar, and then the z, since it is a 95% confidence interval. So, you go to the z table at the 95% means when confidence interval is 95%, then the z value will be coming actually 1.96. Then we are assuming sigma equal to 46 and n equal to 85. So, as a result, so the lower after simplifications, the lower bound will be coming this much, that is 143.222, and the upper bound will be coming actually 162.78. So, that means actually since many managerial kind of problems or business problems. So, targeting to a kind of single value is a very difficult, and so far as decision making process is concerned. So, that is why we like to have a kind of confidence interval, and within that confidence intervals the decision can be more effective and more efficient. That is how most of the problems. So, corresponding to sample informations, we have to create a kind of confidence interval for the population parameter. Likewise, we can have another examples, and then okay, so this is how the looks like the 95% of confidence interval, and here corresponding to the previous examples. So, the lower limit will be this much and the upper limit will be this much, and then your mu will be as usual it is given there. So, accordingly, so the red in the red area, so this is what actually the critical value for the lower range, and this is the critical value for the higher range, and this is what actually confidence interval. So, this portion is nothing but called as a 143.22, and this portion is nothing but called as a 162.78, right. So, this is what the kind of confidence intervals. Okay. Okay, so we will take another example here, and earlier examples we have taken 95% of the confidence interval, and here we are taking 90% of the confidence interval. So, now if you go to the Z tables, then the for 90% of confidence interval, Z statistic will give you 1.645. So, now again assuming actually mean value, standard deviations and n, and then again you will find actually what is the population parameters confidence interval. So, that means actually, so having x bar equal to 10.46. So, what is actually confidence interval for population parameters, and that to the lower limit and the upper limit. Again same structure. So, by using the sample statistics you are actually predicting the population parameter, that too you are creating a kind of confidence interval. Because sometimes to capture the entire population is very difficult, but with the help of sample statistics we can create a kind of range, that to fix a lower range and upper range, and then accordingly the decision making process can be more efficient and can be more effective. So, that means actually after after putting all these value, you can calculate the lower limit is this much and upper limit will be this much, then the probability between this particular series will be nothing but actually 0.90. So, that means actually we are going in a reverse kind of directions. So, here actually we are fixing first confidence interval and obtaining the test statistics. By using the test statistics and the sample statistics, we are creating a kind of interval for the population parameter. That is the objective behind this particular discussions. Okay. So, now okay. So, this is another kind of examples, and here same we are putting actually a kind of things like another example, we are putting x bar equal to 34.3 and standard deviation is equal to 8, and then n capital N equal to 800 and small n equal to 50, and we are putting 98% confidence interval, and at the 98% confidence interval Z is coming 2.33. That is actually from the Z table, and here something actually corresponding to previous two problems. This problem is a little bit different. Here actually instead of sample n equal to 50, here there are two samples, that is n equal to capital N equal to 200 and small n equal to 50. So, let me first give you the kind of clarity here. So, our actually structure of testing is like this: sample, sampling distribution, and then population. Then most of the instances we touch sample to populations, but sometimes we can actually compare with the sampling distribution to the populations. When you are doing actually sampling distribution to populations, then the draw of the sample from the population may be finite and may be infinite, but again under the finite. So, the structure is actually with replacement and without replacement. So, now in the case of without replacement, the standard means population standard deviations will be actually affecting. So, that means in the case of sampling distribution to the population, so mean of the sampling distributions will always converge to the population mean, but variance of the sampling distribution will not actually exactly equal to population variance. So, the standard adjustment between a variance of the sampling distribution to the population distributions will be like this. Okay. So, this is the kind of adjustment factor, and that is the case with there will be difference with replacement and without replacement, and in the case of with replacement, the draw of the sample total sample point will be n to the power n, and with replacement without replacement it will be NCN. So, this is the structure adjustment factors while you are connecting with the variance of the sampling distribution to the populations. So, as a result, after this adjustment, then you have to actually connect with the values of the variables, that is x bar, and then standard deviations, and then putting the value of population sample and small n equal to 50, then you will find the lower bound will be this much and the upper bound will be this much. So, that means corresponding to mean x bar equal to 34.3. So, we are in a position to say population parameter can vary actually between 31.75 to 36.85. So, that is actually the kind of structure we are predicting. So, that means here the idea is in this particular confidence interval, using sample statistics you have to create a confidence interval for the population parameter. So, that means technically population parameter is not actually given. So, with sample statistics we are predicting the population structures. So, if population is given, then obviously our job is just to give comment to the population parameter subject to sample information, but sometimes with the help of sample information we can actually create a kind of confidence interval for the population parameter. That is what we are actually doing here. Now, so this is actually the standard structure about the confidence interval. Actually, there are two different ways when you are using a Z statistic to create a confidence interval. So, in one case your standard deviation sigma is known to you, in one case sigma is known, and the previous two examples where we have actually discussed the issue where sigma is known to you. But there is a sometimes some you will find the issue where you have to calculate the confidence interval for the population parameter where sigma is actually unknowns. Sigma is unknown. So, this is the case where sigma is unknown. Then this same sample information can be used to get the actually sigma value. So, in that case the standard adjustment will be s by root n. So, since the sigma is not available, so from the sample informations you have to find out the sample variance, and that sample variance will be used as a proxy for this sigma component. So, rest of the things are more or less same. So, again once you get the sample statistics, and then with the help of this particular adjustment you will find the lower bound and you will find the upper bound. So, that means again having x bar. So, what is the lower bound for population parameter mu and what is the upper bound for this population parameter mu. So, it is a same structure. So, here there are two different situation. In one situation sigma is known to you, another situation sigma is unknown to you, and both the cases when you apply Z statistic, then assuming that n is sufficiently large. If n is not sufficiently large, then you will follow the t distributions. So, that is in the next slides. So, I will give you the example about the small sample case, but in the meantime, so let us take an examples to justify this particular Z statistic where sigma is not known to you. So, that means in the sample statistic sample information. So, here first you have to calculate the mean, and then you have to calculate the kind of variance, and then n is also given. So, again you have to fix the confidence intervals whether 90, 95, 99 or 97. Then corresponding to the confidence intervals you have to first collect actually Z information. Again this structure is almost all same. So, once you have x bar and Z value and the standard deviations and the size of n, and accordingly you are in a position to find out the lower bound for the population parameter mu, and find out the you are in a position to find out the upper bound for the population parameter mu. So, as a result again having x bar 85.5. So, your population parameter will be ranging between 80.8 to 90.2. So, it will be the lower range and it will be the higher range. So, this is what actually the kind of structure called as confidence interval. Okay. So, again so this is how the standard structure, and you can take confidence interval 90%, you can take 95%, you can take 97%, 98%, 99%. Then corresponding to your confidence intervals you have to first find out the Z value. So, once you find out the Z value, then with the help of sample statistics x bar and standard deviations and the size of the samples, that is n, then you are in a position to calculate the confidence interval for the population parameter. And when you have no information about the standard deviations sigma, that is population parameter, then in that case sample can be used as a proxy for representing the standard deviations. Then accordingly you will calculate the confidence interval for the population parameters. Okay. And then in the third case, when your sample size is actually small and a standard deviation is unknown, then in that case we strictly use t distributions, and in that case z distribution is not appropriate because it is a small sample case. So, but the procedure is almost all same, it is like this. So, in the earlier case, so we are putting actually a z here. So, now in this case we are putting actually t. So, the rest of the things will be more or less same. So, this is what the x bar, and against minus of this much will give you the lower bound, and plus of this much will give you the upper bound. So, only replacement is a t in place of z, and in that when we will applying actually t distributions. So, one of the standard requirement is actually degree of freedom. So, that means to get the t value t criticals. So, you need to know the alpha value, that is either 90%, 95% or 97%, and then again you need to know the degree of freedom, which is nothing but actually difference between n minus k, but in this case k equal to 1, because we are going for one sample case. So, knowing the degree of freedom and alpha, so you can get the t critical. So, the t critical is the one of the input to this particular confidence interval. Then from the samples you will get x bar, and you will get s, and then n will be by default number of counts, and as a result you can in a position to find out lower bound for the population parameter mu, and again upper bound for the population parameter mu. So, let us take an examples and then we will highlight here. Okay. So, this is what the standard examples. So, now from the sample statistic sample informations, you are having actually x bar equal to this much, and then variance equal to this much, and n is 14s, and degree of freedom by default will be n minus 1s, because it is one sample case. So, it will be 13s, and alpha by 2 both the sides you are targeting, then by default it will be coming 0.005. So, again same structure. So, fixing actually x bar to 2.14 and the then the t value. So, for that actually you have to go to the t tables. So, the t tables and corresponding to degree of freedom 13 and 0.005. So, the t critical will be 3.012, and then so 1.29, that is standard deviation is given. So, now corresponding to the n, so your lower limit portions will be this much, and again corresponding to this mean 2.14 and the t 3.012 and the standard deviations 1.29 and n 14. So, this will be coming actually upper bound. So, as a result, so having x bar equal to 2.14. So, your lower limit value will be 1.10 and upper limit value will be 3.18. So, this is how you can create a confidence interval for actually a mu, subject to availability of sample statistic and the kind of choice test statistics. Okay. So, this is another kind of examples, and that too. So, what I will do, I will take you to the example, and let us take an example in the Excel sheet, and I will show you how it is exactly the particular case. And let us see here, and this is actually t distribution, and okay. So, this is the standard examples. So, these are all actually sample points, and I have taken actually 18 sample points, and then so here actually these are the these are the items which you are supposed to know, and our actually objective is to create a confidence interval, and that too the sample mean which will derive from this particular samples. So, first requirement of this problem is to check how much sample size. In this case, which we have already reported n equal to 8. So, what will you do? Just put actually equal to sign, and then you put the command about count and count. So, obviously, so you just give the command about the count. So, automatically you just select the range, and the range will be giving you the idea that it is coming 18. So, that means there are total 18 samples. Then we need to calculate mean of this particular series, again put equal to sign, and then you go to the menu box and put the command about the average. Again you what you will do, you have to select the range, that is starting from A2 to F4, and then put OK, and you will find the mean of this particular series is coming 13.6, and that is one of the requirement for this confidence interval. And again we need actually S, that is the kind of standard deviation. So, which is nothing but actually you just put equal to sign again. Then what will you do? You put actually standard deviation, and standard deviation for samples. So, click here, and again you select the range, that is again A2 to F4, and then you just close the loop, and you will get actually standard deviation equal to 7.80, and then you will get standard error. Standard error is nothing but actually equal to, so the standard deviations divided by the samples, that is the count. Okay. So, it is actually square root of this particular samples. So, square root of this samples. So, square root of this sample. So, you put this okay. So, this is actually standard error, and then alpha we have fixed here actually 10%. So, it is coming 0.1, and as a result degree of freedom will be 17, because the sample size is 18. So, 18 minus 1, the degree of freedom is coming 17. Now, you have to go to the actually first calculate t value, and there is no point to go to the actually t tables. So, here actually Excel spreadsheet by default will give you the t value. So, what will you do? So, you just put equal to sign, and then ask for actually t information. So, this is actually t information. So, it will ask for alpha value and the degree of freedom. So, that is actually this ones, and then and this ones. Okay. So, then you close the loop and put the enter. So, this will create t values. So, now go back to our structure. So, we need actually the lower limit will be x bar, and minus t upon the adjustment factors, and then upper bound will be mean plus the adjustment factors. So, as a result the confidence interval will be like this. So, here what will you do? I have already calculated. So, that means actually so this is actually coming mean value t value. So, mean minus this adjustment factors will give you the lower limit, and mean plus this adjustment factor will give you the upper limit. So, as a result, so your mean is coming 13s, this one is 13s, and then the lower bound will be 10.36 and the upper bound will be 16.75. So, as a result, if you go to these actually okay. So, see here. So, what we have actually in the t case. So, t value which you have already reported, and then x bar we have calculated. So, once you connect with the t with the variance and at the adjustment factor, that is actually standard error. So, this person will give you the lower limit, and again this for x bar plus this much of adjustment factor will give you the upper limit. So, this is what actually Excel spreadsheet is actually helping you to get this lower limit and to get this upper limit. So, this is nothing but actually mean minus, so the t upon the standard errors, and this is actually a t value plus this adjustment factor of standard error. So, as a result, so this clearly gives the signal that having the sample information and sample statistics and the choice of test statistic will help you lot to get a confidence interval for population parameters. And this is one of the typical requirement for any kind of managerial problem, so far as management decision is concerned. So, now with the help of this particular indications, so you may predict the particular environment, and then you can give a fair decisions as per the management is concerned, right. So, in likewise we have actually couple of other examples which I have already highlighted, and this is what we have already discussed after calculating the t value. So, you have to just mean minus upon t adjustment factors and mean plus t adjustment factor, then you will find the lower limit value and the upper limit value. So, again similarly you can also go for population proportions. So, this is also same things. So, here actually this is actually population parameters confidence figures, and this is the lower limit for this is the mean value sample proportions, and then this part is the lower limit and this part is the upper limit. So, likewise actually if you take assume the p value and estimated p value, then your confidence intervals for 90% of confidence intervals, then the kind of lower limit will be 0.12 and upper limit will be 0.20. So, here p is given actually the kind of 0.16. So, having 0.16 sample proportions, the population proportions will be in between 0.1 to 0.20. So, whatever may be the shape of the problem, so you may be in a position to calculate the confidence interval for the population parameter, and these are the things we have already discussed, and with this we will stop here today, and thank you very much.